Hello. Okay, so in this video we will see that how we can perform operations like sorting and all in files, text files which contain large number of words. Okay, for example, this file which is containing around 1,73,500. Okay, this is a large text file. Okay, it's containing one word per line and no spaces, and everything is in lowercase. Okay, so we will take this sample question. In this we have to read a file which is containing one word per line and no spaces, and all the characters are in lowercase, and we have to identify and display two words which are longest and which can be constructed by combining other shorter words which are present in the file. Okay, for example, this is a sample input file. This one we have to print those words which are largest in length and which can be formed by other smaller words, combining them, which are present in the files. Okay, which are also present in the file. Both the largest word and a smaller word should be present in the file. Okay, so for the large file, this one, the sample input is these two words. Okay, so let's see how we'll do this. This is our code. Okay, so first of all, I'm just assigning, this is my location of the file. I am initializing a buffer reader to read this from this particular file, and I am initializing an array list to store all the words. We will use this array list to store all the words of the file. Okay, and here I am extracting each word line by line, because in one line one word is present, so I am just reading that line and storing that in word list. This is array list, name is word list. Okay, and this loop will run till null is encountered. Null will be encountered when end of the file is reached. Okay, so once we have completed reading input, we will close that buffer reader object. After that, I am using this array list for three things. First of all, we don't know how many numbers of words will be inputted in file, so I am using this array list so that dynamically we can increase its size. Another reason is that we will be using this sort function which is available in collection framework of Java, and we can use array list in this, so we don't need to write our own algorithm for sorting. We can use this inbuilt. And third is that we can also use a function contains here to check whether a particular word is present in that array list or not, because the number of word is very large, so these all sorting and checking whether a particular word is present in that list or not is expensive. So that for that I'm just simply using array list, and I'll be using inbuilt functions to sort and check whether a particular word is present in it or not. Okay, so once we have read all the words and put them into word list, we will perform sorting so that all the words are sorted in based on length, because we have to print only two largest words. So how will recognize that who are the words largest? So for that I am sorting the whole word, and for that I am providing if we will just sort, we will just use a default sort function like this, then it will simply sort in alphabetical order, but we don't need that. We need to sort the words based on their length. So I am providing a custom comparer in which two strings are compared based on the length. I am doing a string to str2.length minus str1.length because I want to sort the list in descending order. Okay, once we have sorted the list in descending order, I am running a loop, and I am also having a counter variable. I am running loop till the end of list, or once the counter variable is 2. Because we have to print only two words, so here it is 2. and I'm increasing ith value. I am taking that word from that array list and storing in temp. Then I am setting that word as blank, because we have to find those largest word which can be formed from other smaller word. Here it is, like constructed, like identify and display two longest word in the file that can be constructed by combining shorter words also found in the file. We have to print only those largest file which can be formed by other combining other shorter word. So we don't want that particular word itself to become considered as a other word. Okay, so for that I am just removing that. I'm just putting a blank over there, and then I'm defined a custom function to check whether that particular word is decomposable or not. Means that word, I'm sorry about the background noise. Anyways, so this decomposable function returns true if that particular word can be formed from combining other smaller word. Okay, so I'm just providing that word and the list. If that returns true, then that word is printed and counter variable is increased by 1. And once the counter variable is here it's 0, so it will be 1, and when it's get 2, this loop will be terminated. Okay, so let's see the decomposable function. In this decomposable function, first I'm finding the length of the word, storing that in size. If that size is 0, then I'm just returning true because it's blank, no need to check. Otherwise I am initializing a dp array so that we store the results of all the subproblems, and we can apply the dynamic programming logic here. And we have set the size of this array as size plus 1. Size is length of the word. Okay, then I'm running loop from 1 to end size of the word. Okay, and here I'm just checking whether this string dot substring 0 to 1, that means from starting of that word to ith position that particular substring is present in the array list or not. Okay, if it's present and dp of ith is already false, then we will put true there, otherwise we'll proceed. If dp of I is already true, then this won't be done. Okay, so proceeding forward, if dp of I is true, then we'll check if I is equal to size, means end of the word has been reached or not. If end of the word, this means that why we are storing that dp of I true. So for that we are doing that if dp of I is false, then check if current prefix can make it true or not. So value of dp of I will be true if str.substring 0 to I can be broken down into list of words, otherwise false. It means that if 0 to ith position substring can be broken down into smaller words which are present in the substring, then it's true, otherwise it's false. Okay, so if it's true, then proceed inward. If it's the end of the word, that means that 0 to end all the words can be that substring can be broken down into smaller words. Okay, so for that we are returning true. Otherwise we are running a loop from I plus 1 to the end of word and again doing same thing. We are checking that whether that thing that sub problem has already been solved or not. If that problem, nowhere is not checking sub problem, it's checking that whether that let me see. Okay, so here it's checking that whether that position is true or not, whether it means that whether till that substring any word is present in array or not. If it would be present, then it would be true already. If it's not true, then it's checking wordlist.contain substring dot from ith position till next j characters, like from I to j. It means that I plus 1, j is running I plus 1 to end of the word, so it will check from I to end of the word. Okay, If here is I, then it will check from I, it will check each word from after the ith position till the end of the word. If anyone is found, then it's simply puts true. And here it's also checking if end of the word is reached and end of the word is true. It means that from starting till the end, that substring, that whole word can be broken down into smaller word. So it's returning true. Okay, it is just a simple function using it in testing a little bit. Okay, and if this condition does not becomes true, that if the end of the word is reached and it's not true, then that whole word can be broken down into other smaller words, so it will return false. This whole both loop will terminate and it will return false. Okay, so let's see this into, let's check this by running. Okay, so first we're doing for words file. Okay, so here is a words file, this is a word file. Okay, so these are the two outputs. We will verify rat, cat, dog, cat. Okay, cat, dog, cat, these two. Okay, so let's do that for words1.txt file. This is words1.txt file. Okay, this is a large one. We'll run it. Okay, these are the two words. Okay, these are the two words. So this is the code and same code. Okay, thank you. If you have any comment, then you can comment it below, and I'll try to put the source code link in description. You can check from there. Okay, thank you.